In this video, I'll be talking about the ideal gas law. So, this is the major law that you'll be using to solve for pressure or volume or whatever you're trying to solve, but it's related to gases. And well, as you can see, the ideal gas law is the biggest law, as its name says, ideal. And believe me when I tell you this, something you will never forget is this equation. PV equals nRT. That is the equation for the ideal gas law. So this is what you have to memorize. You really have to know this. Now let's talk about what each of these letters represent. So let's go to another page. The first thing we had was the P. And the P stands for pressure. And we talked about pressure before, so its units will usually be atmosphere, but it can also be torrs or millimeters of mercury. But the one you will most likely use is atmospheres. Then we have the V, and the V stands for volume, and its unit will have to be liters. So if you have milliliters or something like that, you'll want to change it to liters, and now you'll see why. Then we have the N, which stands for number of moles. So well, it'll be in moles. And now we have the R. We've never talked about the R before. And the R is what we call the universal gas constant. So, universal gas constant. And I actually need to talk a little bit more about this, so let's just write it here. R stands for universal gas constant. So this is telling us that it'll be a constant, it'll be a given number every time. So its value is 0.0821. Now, liters atmosphere, liter times atmosphere over mole times Kelvin. So what this is telling us is that we'll want to have our other units in, or our other variables in these units. So that's why we want to have a volume in liters, or pressure in atmospheres, and the moles will say the same. And I didn't really talk about temperature, but I'll talk about it later. So R is based on what we call STP, which stands for standard temperature and pressure. And the standard temperature, so the standard temperature, ST, will be 0 degrees Celsius or 273 Kelvin. Now be careful about this. As you can see, I do not write this degree here in Kelvin because Kelvin is the absolute value. It is not set as a degree Kelvin, it's just Kelvin. And then the standard pressure is 1 atmosphere, or 760 torr or millimeters of mercury, whatever unit you want to use. So if you ever forget about the value of R, you can simply get it by using the PV equals nRT formula. So we have PV equals nRT. Then we solve for R. It'll be PV over NT, right? And we said that R will be in the STP. So we said that the standard pressure is 1 atmosphere. So we have 1 atmosphere in the P. And then let's write the temperature, which was the other thing I said. It was 273.15 Kelvin. This 0.15 doesn't really make a big difference, but it is the exact value. It's not really 273, it's 273.15 Kelvin. And we said that, well, it is 1 mole. And in 1 mole, we have 22.4 liters. So if you're able to remember that the standard pressure is 180 m and the standard temperature is 273.15 Kelvin, and you have 1 mole, and well, in 1 mole there is 22.4 liters, you can obtain the value of R. This will give us 0.0821 and the units, so you can just write them: liters times atmospheres over mole Kelvin. The order doesn't really matter, but I just like writing it this way. So this is how you obtain R, and if you ever forget. And well, I already said it before. The T stands for temperature, and it should be in Kelvin, as you saw, because of the R. I mean, you could change the value of R, like the units, but it's really easier just to change the value of one variable than something that has 4 different units. So if you forgot how to convert your temperature from Celsius to Kelvin, it's only Kelvin will be equal to your temperature in Celsius plus 273.15, and that will give you your temperature in Kelvin. Now let's actually solve a problem using the ideal gas law. So keep in mind, pressure always has to be in atmosphere. So pressure in atmosphere, volume in liters, temperature in Kelvin, and well, moles in moles, the number of moles in moles. Just because of the R value. Now let's go to the problem solving. This problem says that we have an 18-liter container, so that's telling us the volume is equal to 18 liters. We have the right unit. And that container holds 16 grams of oxygen gas. So we have the mass. And they're telling us that it's oxygen gas, so it's diatomic. And this is at the temperature of 45 degrees Celsius. What is the pressure in the container? So let's write our formula. PV equals nRT. We have we're looking for the P, so this is what we're looking for. We have the volume, we have the T, and the R is a constant. So it is 0.0821 liter atmosphere mole Kelvin. So we're only missing the number of moles, but they told us the mass. So I didn't want to do just a basic problem in which you just have to plug in the numbers. So we have to actually convert from mass into moles. And by using the mole diagram that I talked about in one of the first videos, you can do it pretty simply. So 16 grams of O2, we obtain that the atomic mass of oxygen is 16, but it's diatomic, so it'll be 32 grams, roughly, of O2. So this goes with this, and that is the atomic mass is in 1 mole. So we get that is 0.5 moles of oxygen. So now we have the N. So now let's plug this in the formula. Just write here that the N is 0.5 moles. However, there's one more thing that we have to change. This isn't the temperature is in degrees Celsius. We want them in Kelvin, so we simply add up 273.15. So by doing that, we get that it is 318.15 Kelvin. Now we can just plug in the numbers. So first you want to solve for P, so that gives us nRT over volume. P would be 0.5 mole, 0.0821 liter atmosphere, mole, Kelvin. It's really hard to write really small. And then right here, 318.15 Kelvin over 18 liters. So you can see that the units will go, that we have moles up here, moles down here, Kelvin up here, Kelvin down here. And then these liters will go with these liters, just leaving atmosphere. And I get about 0.725 atmosphere. That is the pressure. So really all you have to worry about this ideal gas law problems is getting the right units. So liters, moles, kelvins, and atmospheres. If you can get that, you just have to plug in the numbers and you'll be fine.